Oh,
Okay, so is it visible?
good afternoon.
Good afternoon.
Very good afternoon. Is it visible? My screen, is it visible or
Yes, it's
is
visible.
there any lag?
Yes,
Yeah,
yes,
yeah.
we can see your screen.
Yes, it's visible.
Okay.
Yes, yes, we can see your screen.
Okay, fine. So let me
Good
give a
afternoon.
quick recap. So we were discussing about the cache memory. What is a
Good
cache? What is the concept of cache memory, and uh, how we arrange that? So in the whole memory hierarchy, you know, the cache memory placement, it's between CPU and main memory. CPU and main memory. So the purpose of cache memory to provide data at fast speed. Okay, it will boost your processing speed. So this is the purpose of cache memory. This is the concept of cache memory. Then we understood how it works, like what is cache hit, what is cache miss. So the general thing is when CPU seeks for a data from main memory, so before it seeks a data from the main memory, first it checks whether that data is available in your cache memory or not. If that data is available in your cache memory, then it is, if the processor finds that memory location in the cache, a cache hit has occurred and data is read from the cache. Now next condition, if processor doesn't find the memory location in the cache, a cache miss has occurred. For a cache miss, the cache allocates a new entry. That means it will fetch the particular data from the main memory. It will carry to the cache memory, and then CPU will take that. All this thing happening because we want the data at higher speed. So that's a cache hit, cache miss. Now, here few approaches are there. We can improve the cache performance using higher block cache block size, higher associativity, reduce miss rate, reduce miss penalty, and reduce the time to hit in the. We have some mapping. So mapping is, there are three different types of mapping used for the purpose of cache memory, which are follows: direct mapping, associative mapping, and set associative mapping. Three kinds of mappings are there. From the practical approach, from numerical approach, these mappings are very important. So let's understand the first mapping, which is a direct mapping. But before you understand the direct mapping, let me introduce with the concept of cache mapping, because without cache mapping you cannot understand the direct mapping part. So let me share my screen. Okay, so here so two blocks are there. This is for main memory. Let me write it. Let's say memory, and this is cache memory. Here memory. two memories we have right now. Now so generally when we talk about memory, so generally when talk about the computer part, we say memory in form of bit, byte, bit. Oh, once again. Yeah. This, one second. Yeah. Bits and bytes. We represent memory in the two formats. But when we talk about computer architecture, we always consider words. So what is word? So word is nothing. It's a kind of format, and generally we consider 2 bytes is equal to 1 word. Okay, fine.
Yeah.
1 bit,
Yeah.
8 bits is equal to 1 bytes, and 1 word is equal to 2 bytes. So 2 word byte, 4 word byte. In this way, these are the arrangement. So now come to this point. This is main memory, and we'll talk about the word concept. So here I will write it 128.
1 byte is 1.
So this is the concept for bit, byte, and word. How
1 byte is 1.
1 byte is equal to, yeah, hello, someone was saying that. Please go ahead. Someone was.
No, no, no. I have problems with my connection. Sorry. I just asked about
Hello.
bytes. No, no, no. I have problems with my connection. Sorry. I just asked about bytes. Yeah.
Okay. So actually, we'll talk about a word.
Yes.
So a byte is 8 bits and a word is 2 bytes. 2 bytes means 16 bits. Okay. And double word is 4 bytes. Let's say double word. Okay, let me put that thing. One word is equal to 2 bytes. Clear? This is general thing. 1 bit, 8 bits equal to 1 byte, and 1 word is equal to 2 bytes. So in this way, double word is equal to 4 bytes. This is a general format for your understanding. This is a standard format also. Now, when it comes to this particular main memory, I have considered 128 words. So here, for your understanding, I will consider 128 word means 128 bits. 1 bit is equal to 1 word. Just for your understanding, I have assumed it. Okay. So 128 word length, the main memory length is 128 words. However, you know main memory length is different, but just for our understanding, just for calculation, I have assumed that my main memory length is 128 word. And for cache memory, it's 16. It's 16 words. That's the length of main memory and cache memory. I have assumed it. Now let me write few things. Yeah. Okay, so first thing is, let me write the block. 1, 2, 3, 4, and this dot this partition. So first block is B0, then B1, then B3, and then it will goes to B30. How? Because if you want to check what is the block size, the formula is 128 divided by 4, and that's, if you divide it, you will get 30 blocks. 30 blocks. Once again. Okay, so the block size is 4, and if you divide by total length, then 32 blocks are there. One block, the block size is 4. 4 is a word. 4 words can remain in the first block. So arrangement is W0, W1, W2. W3. 4 words can remain in one block. Then next W4, W2, 5, W6, W7. Next W8, position. Word 9. Word 11. Then word 30. Word 14 and word 15. That's word 15. And in the last one, it will be like a word 24, word 21, 24, 25, word 26, 7. That's the word thing. This many word can 28 word length, and I have 4. You can have 4. So that's a divide 4, 5, 6, 7. That is about the main memory. It's very simple. 2 or 3. This can be fetched by the CPU easily. If you are, this is a separation. Talk about RAM, you call it frame. When you say high, hard disk, it's about paging. Same thing happen in your cache also, but it's very different. So let's say a cache is there. The size is you call it is L. Then here L3. That's a lines. So in main memory, how to calculate lines? 16 words are there by 4, obviously. So it will be sorry. Four lines. So you can say these are lines. So line size, block size, also memory 8 lines. Okay. So this is a concept of cache memory. In cache memory, we call it lines. In memory, we call it blocks. This is arrangement. Now come this part. In the simplest, the first mapping technique is direct mapping. How we use mapping, how we fetch the data, and how a cache stores the data. As you understand, as you know, that cache memory size is very low, but your main memory size is very high. So how it fetch all the data, how it fetch the specific data? So that's because of direct mapping. The first technique is direct mapping. The first technique is direct. The simplest technique known as direct mapping maps it maps each block of main memory into one possible cache line. Understand this line? It maps each block of main memory. As you understood, every block of main memory already that in main memory we divide into two blocks. So each block of main memory into only one possible cache line. Possible cache line. In cache memory format is line, or in direct mapping assign each memory block to specific line in the cache. If a line is previously taken up by the memory block, when a new block needs to be loaded, the old block is trashed. An address space is split into two parts, index field and cache field. Let's see. Okay, so screen sharing it's on. Yeah, is it visible? This screen, Jamboard.
Yes.
Yes.
Okay, so here, uh, okay, so now coming to this particular theory, it is saying cache mapping, and cache mapping means how we fetch data from main memory, how cache memory loads the data, and how it map it, how it reads the thing. And why we are doing it? Because the concept is very complex. How? Because your main memory, that length is very high. You use a high length memory devices in main memory, but your cache memory that is very limited, 3 MB, 5 MB, 10 MB, I guess 5 MB and 7 MB, that's the maximum size generally we use it. So my concern is to understand how a 7 MB cache memory can load a block of data, a block of a memory, of how a specific part can be loaded by this cache organization. So that's why I was explaining. In computer, we use bit, byte, and word. And in computer architecture, we always say word. Word is a general format for computer architecture field. So if one word, if you assume one bit as a one word, just for understanding. So here I am considering a main memory. The length of this main memory is 128 word. 128 words. That's the length. And this is arrangement, because if 128 words are there and each word 4 blocks in one block, blocks are maintained: block 0, block 1, block 3, block 4, and block 31. In the blocks, 4 word can exist. 5 divided by 4, 32 blocks will be created. So in main memory, we call it blocks. And when you do this thing in a cache memory, it's line. The unit of the memory in cache memory, we call it line. So that's we need to understand that theory is saying the simplest technique in direct mapping, known as direct mapping, map each block of main memory into only one possible cache line. Or you can say assign each memory block to a specific line in the cache. So each memory block to a specific line in cache. Here you can see that this is block 0. Here block 0 is there. Block 1 is there. Block 2 is there. These are positions of blocks and you cannot change it. The problem is you cannot change it. That's why it is called as direct mapping. So let's say if you have stored any data like in this word for location, this is word for location. So in word for location, this comes in block 1. So it will saved in cache memory in L1. In line 1, it will be stored and CPU will directly fetch it. So here, these blocks are maintained. So if it is stored in the cache memory, so quickly CPU will fetch it. And here CPU is here. This is CPU. Okay. This is CPU. And CPU fetch from first it checks in cache memory, then in main memory. So it will check whether that blocks are available or not. If blocks is there, then it will load it. So in this way, a small cache memory holds this much of data. Now the thing is how I have allocated this B1, B0, B2, B3 in this way. First of all, this is a specific place for this one, but there is a formula also for cache memory or block allocation. The formula is K mod N. So K stands for block number. It stands for block number. K means block number. Mod is modulus, and N for number of lines. It means number of lines. Number of lines. So block number is B0. Let's say B0. So B0 means mod 4. Number of lines, 4 lines are there. 1, 2, 3, 4. Okay, so we need to get which the block number, the block 0 will be allocated to which particular one. So what is the 0 mod 4 means? If you calculate the mod 4, mod means modulus. So what is 0 mod 4? What is the answer of 0 mod 4? Hello. Hello. I'm audible. Okay, let me check my speed. Okay. Uh, hello, hello.